Hello friends, in this video we will see the applications of dimensional analysis. So first application of dimensional analysis is to check the dimensional consistency of any equation. Any equation cannot be accepted as the equation of that quantity unless and until it doesn't satisfy the dimensional consistency, or if it is not dimensionally valid, then it will never be accepted as a formula for that quantity. So let us understand what exactly this dimensional consistency is and how to check. So for that let us take an example, a very simple example of energy. So energy has two formula. One is half mv square, which is a formula of kinetic energy, and another is mgh, which is the formula of potential energy. So we know that dimensional formula of energy is m1 L2 t to the power minus 2, and if half mv square and mgh, if they both are dimensionally valid, then they should have the dimensional formula same as that of energy. So let us check. First rule is any constants should never be involved in dimensional analysis. So 1/2 here will be neglected, and we know dimensional formula for mass is m1. Dimensional formula of velocity is L1 t to the power minus 1, and hence, and as v has a square on it, we have to square this. So we will be getting m1 L2 t to the power minus 2, which is same as the formula of energy. Hence I can say that my half mv square is dimensionally valid. Let us check for mgh. M here is mass, so m1. G here is acceleration, and acceleration has a formula of meter per second square, that is L1 t to the power minus 2, and height here is a length, that is L1. So my overall dimensional formula is m1 L2 t to the power minus 2, which is again same as energy. Hence I can say that formula mgh is also a dimensionally valid formula. So this is how we can check the dimensional consistency of equation. Your LHS should be equals to RHS. Both should have same dimensional formula. Then I can say that they are dimensionally valid. One more rule that you should know is, for example, a law of homogeneity. For example, I have a formula of distance. X is equals to x naught plus v naught t plus 1/2 at square. Here, make sure whenever you determine anything or any LHS, here it is a distance. It is a formula of distance, or we can say displacement. And it has three terms. One is initial displacement, another is initial velocity multiplied by time, and the last one is 1/2 acceleration into square of time. So the dimensional formula of x, it will be m0 L1 t0. It is just an L1. It should be same as x naught v naught t and 1/2 at square. If from all three terms, if any one of them doesn't satisfy these dimensional equation, then whole formula is dimensionally invalid. We cannot apply, or we cannot utilize this formula as a formula of distance. So let us check. Here x naught is an initial distance, hence it has a dimensional formula of L1. V naught into T. V naught means meters per second, that is L1 T to the power minus 1 multiply by T to the power 1. T to the power 1 minus 1 will be cancelled out and formula will be L1. Here half is constant, we will not include it in the dimensional calculation. And acceleration has a dimensional formula of L1 T to the power minus 2 multiply by square of time, that is T square. T square T to the power minus 2 will be cancelled out, and here dimensional formula is L1. Hence I can say that all three terms has same dimensional formulas of L1, 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 and here also we have a dimensional formula of L1. Hence I can say that law of homogeneity means if your equation has more than one term, it could be two term, it could be three terms, then all three terms should have same dimensional formula as that of your LHS. Now another application of dimensional analysis is to determine, or we can say derive formulas and determine the powers in expression. Let us take an example. For example, time period of a pendulum. We know that it depends on two things, that is length of a pendulum, and another is acceleration due to gravity, which is called g. Now I don't know what would be the power of L. It could be L square into g cube, it could be root L into root g, it could be root L by root g. I don't know the power. So to know the power, we have an option to use dimensional analysis and to determine their powers. This is also one of the application of dimensional analysis. So let us see how it works. So for that, write down time period of a pendulum is equals to L raised to A into B into G raised to B. I don't know, these powers are unknown to me, and I'll be finding out these powers at the end of equation. So we know that time period has a dimensional formula of m0 L0 t1. Length has a dimensional formula of L1, which is raised to A, and G, which is acceleration due to gravity, has a dimensional formula of acceleration, that is meters per second square, L1 T to the power minus 2, and it has a power of B. Expanding it, L raised to A, L raised to B, T to the power minus 2B. That is equals to L raised to A plus B, T raised to minus 2B. Now comparing it with M0, L0, T1, here you can see I don't have any term on both LHS, RHS which has any term in terms of mass, and here length L0 I can compare with A plus B, as I can say that A plus B is equals to 0, and time, that is minus 2B, I can compare with 1, and I can say that another equation I'll get is minus 2B is equals to 1, and from this I can say that B is equals to minus 1 by 2. Now substituting this value of B in this equation, I can say that A minus 1 by 2 is equals to 0, and A is equals to 1 by 2. So I have got the value of A, I have got the value of B. I'll replace those values here. I can say that time period is equals to L raised to A, and A has a value of 1 by 2 into G. G has a value of minus 1 by 2, and I can write down this formula as root L into 1 by root G, which is same as root L by G. But originally time period has a formula of T is equals to 1 upon 2 pi root L by G, and these constant cannot be determined using dimensional formula. So this is one of we can say limitation of dimensional analysis. We can only determine power of the required quantities, and we cannot determine the constants. So whenever in exam, if they will ask you to determine the power, they will already give you constants in the equation, or we can say in the question. Hope you have got this point. Thank you.